The Antarctic is this absolutely incredible place. It's a contradiction. It's one of the driest places on Earth, and yet it holds 70% of the world's fresh water.
Antarctica is big. It's larger than the continental United States.
It's so incredibly cold. It's the coldest place on Earth at the surface. At the base of the ice sheet, it's melting.
We're talking about a big, inaccessible chunk of ice that is probably some of the most unexplored territory on the planet.
Today, we have maps every single year, complete coverage of the Antarctic flowing into the ocean. We're looking at all these changes. We've got lasers in space measuring very subtle changes in the shape and the topography. I mean, what's it going to look like in 10 years from now? Right? I mean, our understanding is it's exponential. It's amazing how little we knew and how much we know now, and how much there still is to learn.
I totally agree. And I think what's wicked cool about that is both the remote sensing component and the glaciology component. Those have really accelerated and transformed inside units of time that are comparable to like the age of us. That's pretty cool that we're working in fields where we've seen that sort of that logarithmic just take off. I totally agree. I think some of the history stuff that's fun to look at.
It wasn't long ago, in the 1960s and 70s, that satellites were only able to catch snapshots of Antarctica. They were single moments in time, few and far between.
And liftoff of
It wasn't until decades later when Landsat 7 started to reveal detailed features of Antarctica that signs of change could start to be seen. At the ground level, NASA first stepped foot on the ice sheet in 1983, when Robert Binchadler began studying the behavior of ice streams along the coast of the Ross Ice Shelf. Over the decades, the combination of efforts on the ground, air, and space helped NASA develop game-changing ways of mapping the unexplored places on the continent.
We don't have a high-resolution map of Antarctica to date, but this will be the first high-resolution map that's available to the science community, 25 meters in resolution.
LIMA takes us from the world of black and white TV. LIMA is true color, high-resolution representation of Antarctica. It's a step change.
And then it wasn't until 2011 that we had our very first map of how the surface of the ice sheet moves, right? Because the ice sheet is ice that is flowing into the ocean. It's moving everywhere.
I think, what Alex was getting at, what is our look and our mapping and our view of Antarctica going to look like in 10 years? And I hope we have a better three-dimensional sense of the ice sheet, that we have a very good sense of the bottom. We're getting at the resolution of different things that come down to basin scale, things that we didn't really have before. So we're looking at things at dynamics and systems at a much smaller, a traversable, is that a word, type scale.
Yeah, so there's REMA, Reference Elevation Model of Antarctica. It's incredibly high resolution, incredible detail, and gives us some of the most precise knowledge we have of the ice sheet elevation. And we're able to use the data for practical things like initializing a model, a numerical model of ice sheet flow. And so having these types of data sets just lets cryospheric scientists get to work that much faster and generate conclusions from the data that are just that much more robust.
I've spent a total of about, a little over 2 years in Antarctica on the ground. And some of that was with research that I've been doing recently with NASA, and some of it goes back to kind of, your first jobs out of school and whatnot, doing GIS and remote sensing for the science support contractor that's in Antarctica.
The U.S. National Science Foundation operates 3 permanent stations in Antarctica, which provide the facilities for scientists like Kelly to do some pretty remote research.
And then more recently, I've been working on the 88 South project, which is going down just after Thanksgiving, missing Christmas, coming back kind of in late January, doing a big science first base out of the South Pole Station in support of ISAT-2. We come out of the base, drive a 300-kilometer stretch along 88 South, and then go home. It's 750 kilometers total.
Work and life at the pole is harsh. It's cold, very cold. And it's very dry. Antarctica is a desert, after all. And there's wind. Relentless wind with nothing on the landscape to break it up.
The other environmental issue that I see is, this is huge too, is elevation.
What you doing, Kelly?
Closing up the GPS. Trying to breathe.
Trying to breathe? What's the problem with your breathing?
We're at 10,000 feet above sea level. Getting higher every day, it seems.
You know, you can get out of the temperature, you can get out of the wind, but you're at 10,000 feet, period, and you can't get out of that.
The crazy thing is I can look at a satellite image of the Antarctic, and even with a fairly small postage stamp, I can tell you where it is. And I have never been to the Antarctic. I feel like the fanboy that just can't afford the ticket to the concert.
Is it strange knowing so much sort of geography about a place, having not been there? Or
how many other people just stare at imagery of places they've never been and understand it in, you know, deep ways that maybe people that have set foot on the continent never even thought about it. It actually takes quite a while to build trust between those communities, because they have these different kind of worldviews of how things are. When you talk to somebody on the ground, especially in the past when remote sensing was just starting to become more prominent, there's an inherent skepticism that you can't see what I'm seeing because it's so detailed and it's so nuanced. And the people that are looking from the satellites down often feel that the world is so big and so massive and moving in so many different ways that how could you possibly understand it from putting your feet on the ground and looking at a single spot.
One of Alex's current projects is comparing the Antarctica of today with the Antarctica of the past. The problem is NASA's satellite imagery only takes us so far back. To go back further, Alex needed another agency's satellites.
The first satellites were not for scientific applications, they were for military applications. There was a series of satellites, still some of the most expensive ones that we know about.
Its name, Hexagon.
And they were these short-lived satellites. You know, this was during the Cold War, and they were really designed to keep tabs on the Russians and where the missile silos were. But they were collecting imagery other places. They were using analog cameras, so that means they had film. And they'd have these gold canisters full of film, like miles of film. And they would deorbit these canisters when they would get over the US. These canisters would re-enter through the atmosphere, and they would deploy a parachute, and then a plane would actually go and grab these canisters mid-air and then bring them down, develop the film, and then analyze them for all the different targets. We've had a big project where we've tried to scan a lot of that imagery through the USGS so that we can analyze that imagery to see what the Antarctic looked like back in the 70s and how it's changed up until now.
I get asked a lot, like, how did you get into this? And I think it was because my family, what we did for family vacations was load in the car, go up north, and go skiing. Mm-hmm. And so what I remember as a kid is snow, and it frustrates me when, you know, I see short winters and whatnot, or, you know, not a lot of snow. It bums me out. So I think that's how it started.
I did 2 years of engineering, and then I kind of got restless, and so I went and traveled South America with my wife-to-be and found myself sitting in front of the Moreno Glacier at one point, wondering if this was something that anybody had ever thought about studying, and also starting to realize that these things would probably change a lot in the future. And I remember I was just in awe. I mean, it was, you know, these 10-story buildings of ice crashing off into a lake, and I had never seen anything like that with that much power that I could witness in real time. I just sat there and watched it until my wife dragged me away because she was ready to go. That was kind of occurring at the same time that I wanted to contribute to something big societally.
There's an amazing photo taken by Apollo on its last mission that everyone's seen it. It's the base of Earth as a disk, and in the center of the frame is Africa. And what you fail to really realize is if you look down at the bottom of that, the bulk of Antarctica is in that photo too. And it's kind of the first time you get a really big remote sensing full look at the continent. We need to do this again, get people back on the moon, to re-spark that interest in sciences and engineering. When I talk to my colleagues that are a bit older than I am, a lot of them say that the Mercury, Gemini, Apollo, that type of activity got them into engineering. We need that again. So I think this is fundamentally important to kind of keep NASA and that exploration, that engineering, that getting kids and adults interested in science.
I get frustrated that we're likely already crossed certain tipping points. And I get apathetic that we're not taking more action and that I'm not having enough of an impact. And that really frustrates me and kind of makes me feel down. But then I thought, you know, where I started on this journey, which was staring at a glacier in South America in 2007 or 8, where I am now and kind of the influence that I'm able to have, you know, to do my small part in this big picture, it's kind of one of the like, don't give up stories, right? Like we are making progress. We are getting through. Our voices are starting to resonate, and we just can't give up because there's still a chance to kind of turn this thing around.